Hello and good day. Pre-algebra, we'll be going over your quiz from PO20 and then getting into PO21. Happy Monday to all. It's a short week this week. I will once again be out, but I will be back Monday the 30th. So happy early Thanksgiving to all, and I'm sure I'll wish you that again tomorrow. But anyway, getting to the quiz, PO20, our second attempt at two-step equations. It's fitting we would have two quizzes on two-step equations. And this went quite well. At this point, it's almost noon on Sunday, and only about half of you have responded. But from this, I was able to kind of pick out some questions that struggled with more than others, and we're going to talk about those before moving on to PO21. So the first one, solve for the variable negative 11n minus 16 equals 6. I'll write it again here so I can work with it, and you can all see it. As with any two-step equation, we're looking for what are the operations that are going on in the equation, and then how do we undo them. And we start with any addition or subtraction, start with that constant. Our constant in this case is that negative 16 there. Do recall that sign does belong to the 16. It's a negative 16. So to undo that, we're going to be adding 16 to both sides. Those cancel out because negative 16 plus 16 is 0. And negative 11n will equal 22. Okay. Now to get n by itself, we can divide by negative 11. So that's the opposite of multiplying by negative 11. And we get n equals negative 2, which is the fourth answer here. So a couple things that I kind of tried to throw at you. If you divided in this step by positive 11 instead of negative 11, then you'd have gotten positive 2, which is that answer, but is not correct. If you added, again, in this step here, instead of dividing by negative 11, if you added 11 to both sides, then you would get n equals 33, which is not correct. You would not add in this step here because that negative 11 is not a constant. It's that coefficient. It's being multiplied by n. So to undo that, we would need to divide. Okay, and then to get negative 242, what do I do with that one? I think if you multiplied by 16 and then multiplied by 11, I don't know what. Oh, no. Yeah, if you were in this step again here and you multiplied by negative 11 instead of dividing by negative 11, that would get you negative 242, which is also not correct. So really, I took it from this step here. If you handled that correctly and divided, then you should have gotten the correct answer. So that was one of them. And the other one was further down the page here. This one, yeah. Using the opposite operations method, which two operations would you need to do to solve for the variable in negative 8n plus 3 equals 27? So what you're doing here, when I say what you need to do, as you are working through the process to get n by itself and find the value of n, based on the operations in the equation, what would you need to do to solve it? Okay, so first, you would need to subtract 3 from both sides because that's the opposite of adding 3, right? Cancel that constant out. So that will leave you with negative 8n equals 24. So since we subtracted, we can eliminate that one because not underline it, eliminate it because we didn't, that one doesn't have subtraction as an option. So that kind of leaves us with now the other 3. We would divide by negative 8 because that's the opposite of multiplying by negative 8, which is what's happening to n here. And so n is by itself, and that gives us negative 3. So it's that subtraction and that division. Option 4 is the correct answer. Okay, we aren't going to add and subtract because adding and subtracting, they don't get rid of that coefficient. That can only be done by multiplying or dividing. So it's not going to be both of those. That's why that one's out. And subtraction and multiplication, we do subtract first, but again, to break this up, right? This right here says -8 times n. And to undo that, we're going to be dividing. Okay, thus we have subtraction and division, not that one. So the reason why we spent 2 days on two-step equations with 2 quizzes is because going forward in PO21 and PO22, two-step equations are going to be our goal, in the sense that the equations that you're going to see going forward are going to be longer. They're going to be more steps, multi-step, but once you get to that two-step equation, then it's just, add, subtract, multiply, divide. Add, subtract, multiply, or divide, right? So I want the two-step equation to kind of be your comfort zone, your home base. Like once you get here, then you're good to go to get n by itself. So let's take a look at what PO21 has in store for us today. These are multi-step equations, and the word multi just means in this case, more than 2, right? And so what I want to point out about about PO21 is that PO15 is going to be a big help in solving these equations. Because if you look on this page, combining like terms, where have you seen that before? PO15. You go down the page a little bit further. The distributive property, where have you seen that before? PO15. The thing about PO21 is that you're really not learning anything new, okay? Because if you know how to combine like terms, which we've done, if you know how to distribute, which we've done, that's going to be how you get to your two-step equation. And once you get to that two-step equation, then it's just add, subtract, multiply, divide. Okay? So when solving a multi-step equation, we are going to, how do I write this? Essentially work to get to a two-step equation. Okay, work to get to a two-step equation. No, I didn't spell two wrong. I just can't make a W. Okay, work to get to a two-step equation by either combining like terms, okay, or using the distributive property. And if you remember, the combining like terms method, the goal of this was to exactly kind of what it says. Combine like terms, and those would be terms with the same variable or constants, which are terms without a variable, right? So we're looking to simplify the expression. The biggest mistake that gets made when combining like terms is, remember that, if you're simplifying an expression, you're only working with one side of an equation, meaning that you do not use opposite operations to combine like terms. You only use opposite operations when you're moving something from one side to the other, right? When we were doing PO15, we didn't talk about opposite operations at all. We didn't introduce opposite operations until we started to solve equations and move terms from one side to the other. Okay, if you're not moving a term, you're just combining it, you're not using opposite operations. So, for example, this first one here, 6x plus 4x equals 50, right? I'm not going to be subtracting 4x from there and 4x from there. I'm not going to be subtracting 4x, here's what some people do also, subtracting 4x twice from the same side, okay? What I'm doing is I'm looking at the left side of the equation and I'm saying, okay, I've got some like terms here, right? Rather than saying you've got 6 x's and you add 4 more x's, isn't that just the same as having 10 x's? The right side of the equation didn't change at all. That 50, nothing happened to it. Okay? I'm not moving terms from one side to the other yet, so I'm not going to be using opposite operations. I'm just combining my x terms. Now that I've got the equation 10x equals 50, and I can't do any more simplifying, now I say, okay, I'll use opposite operations because I want to actually move that 10 over to the other side or undo that operation of what's being done to x. I'm actually solving now. The first step was just simplifying. Now I'm actually solving. Divide both sides by 10 and x equals 5. Again, nothing new, right? We've combined like terms before. We've solved equations before. Okay. Let's take a look at the fourth one here. Okay. Since you always ask for the last one, we'll go ahead and do the last one. And so I'm looking at this, and like terms, this is definitely a multi-step equation. I've got two terms that have an n, so I'm going to be combining those. And I've got two constant terms, positive 7 and positive 3. So I want to be combining those, right? And my new equation now is 10n minus 2n. That gives me positive 8n, just 10 minus 2. I'm not adding 2n to both sides here, right? I wouldn't add 2n here and then add 2n here to cancel that out and get 12n, because I didn't do it to both sides, right? It's like I added 4n to the same side by adding 2n twice. And I certainly wouldn't, add 2n to this side. First of all, because I can't combine a constant 2 with 2n. And second of all, that's not how we combine like terms, right? We don't move things over, okay? We just look at what we have. How many n's do we have total here? Positive 10 minus 2, we've got 8. So no opposite operations there. Then with my positive 7 and positive 3, well, 7 plus 3, positive 10, right? 8n plus 10 equals 2. Again, that right side, that 2, didn't change at all. I didn't do anything with it. There's no simplifying that can be done on that side of the equation, so I just leave it as a 2. Okay? And now I've got my two-step equation. Now I'm in my comfort zone. Start with my constant, move it to the other side. Second step, leave yourself some space. Second step, multiply or divide, negative 8 divided by 8, n equals negative 1. Oh boy, let me try that again. N equals negative 1. Okay, so I hope that you were seeing here that it's really not a new concept that we're learning today. It's kind of the combination of PO15 and PO20, in that you'll have to simplify one side of the equation first by either combining like terms or distributing. Once you do that, then you've got your two-step equation that you can solve. Okay, so it's PO15 first, then PO20. So these two questions here, I'm going to put on your quiz that will be due tomorrow. So you have kind of two examples here. If you are looking at this and you're like, what? I don't really get it. Okay, look back to PO15, how to combine like terms, review PO20, how to solve a two-step equation. That's really all this is. Okay. The distributive property. Let's scroll on down. Distributive property. Okay. The goal of the distributive property is to get rid of the parentheses by multiplying each term. I'll go down here. Sorry, I should have given you two lines for this one. On the inside, by the coefficient on the outside. Okay? The goal of the distributive property is to get rid of the parentheses by multiplying each term on the inside by the coefficient on the outside. To get rid of the parentheses by multiplying each term on the inside by the coefficient on the outside. Okay? Again, we'll do the first and the fourth ones here, and the middle two will be on your quiz for tomorrow. There is a whole second page to this. Don't go there yet. I want to see how this quiz kind of goes, if we're kind of getting the general idea, and then we'll hit that second page tomorrow before the long break. So 7 times n minus 5 equals 42. To undo those parentheses, get rid of those parentheses, because this is not a two-step equation right now as it's written, okay, yet, as far as what we're looking at today. And so we're going to start by distributing that coefficient, that 7, to both terms inside of our parentheses. And remember, we're doing this by multiplying. 7 times n, 7n, 7 times negative 5 is a negative 35. Pay attention to your signs, right? That subtraction sign is a negative that belongs to the 5. So we get 7n minus 35 equals 42. Two-step equation, comfort zone. Start with that constant, move it to the other side, and notice I'm using opposite operations now because I am moving it, right? 42 plus 35 is 77. Second step, multiply or divide. And 77 divided by 7 equals 11. I did not do this on the above equation. Shame on me, but I should be. Once you get that answer, check it, right? Does 7 times 11 minus 5 equal 42? Well, our parentheses, 11 minus 5 is 6. 7 times 6 does equal 42, so it checks out. Okay, checks out. The fourth one, a bit more complicated here. I do have those parentheses. And for situations like this, when we kind of took the quizzes on PO15, these equations kind of gave us a little bit of trouble, okay? Because we have to recognize here that the coefficient to our parentheses is only that number right against it, right against the parentheses. That 3n, that's separate. We're not going to use that yet, okay? What we're distributing is that negative 3. Again, that sign belongs to it. That negative 3. So negative 3 times 8n is a negative 24n. And then a negative 3 times a negative 1. This is where a lot of people lost their signs here, mess up the signs. You have a negative times a negative. That's going to be a positive. Okay? And here's a situation where even after distributing, we're not done yet, right? This is not a two-step equation yet. We've got like terms here that we can combine. 3n and negative 24n. I've got 3 n's. I subtract 24. I'm left with negative 21. Again, no opposite operations here because we didn't move anything from one side to the other. We are still simplifying on that left side. You're not going to use opposite operations until you get to that two-step equation, which is where we're at now. Okay? Start with that constant. Move it to the other side. Negative 21n equals 3 minus 3, which is, oops, I forgot the n. Equals 3 minus 3, which is 0. Okay? So, negative 21 times what number equals 0? Right? 0. Okay? And we still get that by dividing both sides by negative 21. 0 divided by negative 21 equals 0. Okay? 0 divided by anything equals 0. And if we go back and we plug this in, does 3 times 0 minus 3 times 8 times 0 minus 1, does that equal 3? Well, 3 times 0 is 0, right? So then we have negative 3 times 8 times 0, which is just 0, so I might as well mark that here. Minus 1, negative 3 times 0 minus 1. Well, 0 minus 1 is negative 1. So does negative 3 times negative 1 equal positive 3? You bet it does. Okay, so it checks out. All right, these two equations will be on your homework quiz. Both multi-step, both requiring the distributive property. That third one, kind of like the one we just did, though it has a little bit extra. I'm going to tell you right now, don't go adding 2 and 8 first and then distributing in the 10. Remember, that breaks the order of operations, right? You've got to distribute first, multiply first, bring that 2 down, and use it in the second step like we did with that 3 in there. So don't worry about the second page, just a short quiz, just kind of see where things are at with PO21 at this point. I'll review them tonight and see how we're doing for tomorrow. Have a tremendous day, folks. Do not forget to like and subscribe.